Dr. Balakrishnan Manikam completed his doctoral degree in physics from IIT Chennai. He joined Indian Space Research Organisation in 1984. He coordinated the setting up of NNRMS, National Natural Resource Management System in the country, which helped to promote the use of satellite observations in assessment natural resources, disaster mitigation and environment protection. Dr. Balakrishnan coordinated several national projects and helped in setting up of advanced laboratories for satellite data analysis in the country. He also played a key role in developing several indigenous weather instruments such as automatic weather station, GPS sound and LiDAR and establishing networks across the country. He worked as an expert in remote sensing at the United Nations program Bangkok for over 15 months. He has traveled widely and helped as consultant in several countries to set up facilities and training in satellite applications. He has about 25 years of experience in teaching in the areas of physics, mathematics, space science, atmospheric science and applications of remote sensing and GIS. Dr. Manikam has over 200 published papers in peer-reviewed national and international journals. Currently, he is a visiting professor in Bangalore University.
Welcome to the UGC lecture series on environmental science. Today's topic is impact of drought, climate change. We are all very well aware of the importance of weather on human life. Anywhere two persons meet, the first topic they talk is about weather. And it is very interesting to note that Earth system is one among the very few systems in the universe which supports life. This is because of the very unique weather Earth is having. The average temperature is about 15 degrees centigrade. Adding all the Arctic and Antarctic snow cover, the highly warm areas of the equator and the oceanic areas, if you take an average, it is about 15 degrees centigrade, very ideal for the supporting of human life, human and other life forms. Basically, this has happened because of the very particular positioning of Earth from the Sun. We have got other planets in our planetary system, but none of them can support life as Earth can support. Basically, the distance of the Earth from the Sun has decided this average temperature, and it is also the inclination of the Earth with respect to the rotating axis, that is about 23.5 degree, has helped in formation of seasons. Basically, there are three main seasons: summer, winter and rainy season all around the world. Very near to the equator, the central portion of the Earth, you have got very warm areas, warm oceans are there. As you go away and away to the poles, the temperature decreases and almost it becomes about minus 40 to minus 50 degrees centigrade as you go to the Arctic and Antarctic snow covered areas. This is a very particular system of weather that occurs over the Earth. And weather system is very complicated in the sense there are many players. The atmosphere, the land, the ocean, all these play a part in the formation of the weather. To the extent that we all know about Albert Einstein, one of the leading scientists in the world. He was asked which are the subjects which he would not like to work on. He answered, one is weather science and another is political science. Let us see now what are all the different weather parameters. The weather is actually the state of the atmosphere. It defines the state of the atmosphere. Like a human being, you take the blood pressure, the temperature, the salinity in the body and different aspects decide the state of the human being. The similar way, if you consider the atmosphere, the very important parameters are, one is temperature, atmospheric pressure, then you have got the humidity, the amount of water vapor in the atmosphere, then comes the winds that are blowing across the atmosphere, and ultimately the rainfall. These are all the very important parameters, and since time immemorial, human beings has been very interested to know what are these parameters, how they are changing, why this complex system is there, and ultimately for the human benefit, the rainfall is very, very essential. Clouds form a very important parameter in the weather. Clouds are something like the ultimate effect of weather. In an area, when we see the clouds, we know there is a weather system. It can be a low pressure, it can be a depression or deep depression or even a cyclone, depending on the severity of the system. But basically, the clouds are always there. At any time of the year, around our earth, at least 50% of the area is covered by clouds, depending on the seasons. Now, what are these clouds? They are basically made up of water vapor. You cannot see the clouds when they are very near to the earth. Clouds are a very important parameter in the weather. Clouds are like indicators that there is a weather system. For example, the weather system can be a depression, deep depression, a low pressure area. Now, what are these clouds? They are masses of small water droplets or tiny ice crystals that float in the air. It is very surprising. These water drops, these ice crystals, they are floating in the air, and when they reach a higher level, then only we can see the clouds. We cannot see the clouds when they are very near to the surface of the earth, because they are still in the form of water vapor, which we cannot see. But as we go up and up in the atmosphere, a particular height 0 degree centigrade isotherm comes. After that, the clouds become liquid water, then water drops are there. That is the time when the cloud gets a white color, white and black color, in different colors they get, depending on the amount of water vapor available, amount of liquid crystals available in the clouds. Now, what are the different types of clouds? Basically, depending on the heights, we have subdivided them into 3 classes: cirrus, cumulus and stratus. They are actually Greek names. Cirrus basically refers to very high level, about 12 kilometers, 10 to 12 kilometers level. Cumulus is the medium clouds, which are about 5 to 7 kilometers high, and stratus clouds are plain clouds, very thin clouds, which will be just floating around at a height of about 2 to 3 kilometers. Now, there are many different types of clouds which are formed by combination of these things. There is a mixture of all these things form lot of clouds, and during my lecture I will elaborate on how these clouds are forming and what are their different characteristics. Now, let us see the formation of the clouds. The basic input for the clouds is a radiation, the transfer of heat by radiation from the sun to the earth. And while the radiation is coming from the sun and falling on the earth, it has passed through the atmosphere. So, what happens? It heats up the atmosphere. The different levels of the atmosphere get different temperatures. This is the radiation. Then another mode of radiation transfer is by conduction. Conduction is the molecules touch each other, they are moving up and down, and they are coming in contact. When they come in contact, they transfer energy. And you can see the picture below in the slide, how small air parcels like bubbles, they form and they start rising and they go up and up in the system. And here you can see another 2 modes of heat transfer in the atmosphere. One is convection, which is very important for all weather systems. What happens here is a whole fluid mass of air which is heated up starts moving up. It is called as a air bubble, and these bubbles start moving up in the atmosphere, and as they go up and up, you can see they actually increase in size. Their size increases, because in the atmosphere, if you see, very high pressures are there in the lower surface, and as you go higher and higher, the pressure reduces. It is like a balloon. When a balloon goes up, it expands because of low pressure in the atmosphere. Same way, these air bubbles also, as they go up and up, they increase in size, and ultimately they become clouds. And first, actually very small clouds are formed, and these clouds then join together and become bigger and bigger clouds. This is what happens in the case of convection, and this is the basic process of weather formation. Now, what are the conditions for weather formation? Let us see. See, air, if you consider the atmosphere, it consists of different molecules like nitrogen, oxygen, hydrogen, carbon dioxide, water vapor, a number of gases. You can assume them as a fluid, like a liquid, it is a fluid. So, the fluid dynamics holds here. Basically, the equation is with reference to the pressure. Where pressure is low, the air will start coming from the high pressure to the low pressure, and the winds are formed. So, basically the wind is formed because air starts flowing from high pressure to low pressure. And in the atmosphere, there are different regions of high pressure, different regions of low pressure. This is what forms the weather. Now, this equation is called as the hydrostatic equation, which connects the movement of the particles or the wind with the pressure gradient. You can see here dP by dZ is the pressure gradient, and this is connected to d squared Z by dt squared, which is the acceleration of the particle. That is, the particle is accelerating because of the pressure gradient. And here one more very interesting component comes into play is the gravitation. See, you know very well the earth is attracting all bodies. A stone you throw up, it comes down because of the gravity. The same way, all these molecules are also attracted by the gravity. So, a gravity term also comes. This is called the hydrostatic equation, and this equation is run in the computer to know where the cloud is moving, where the clouds are forming. This is the basic equation. Now, you can see how the clouds, as they go up, they increase in size and they become a bigger clouds. And when the clouds coalesce, when they join together, they become a very big cloud. And those big clouds, because of the large amount of water vapor, water, ice crystals, they start forming raindrops. And it is interesting to note that raindrops, what starts from the cloud is about 5 to 10 times bigger than what we see in the earth. You see in the earth actually half a centimeter or quarter centimeter like that, small droplets. But these droplets, when they start from the cloud, they are 10 times bigger. As they come through the atmosphere actually evaporates them because of the temperature difference. It gets evaporated, and only a part of that drop we are able to get in the earth. Now, let us see another aspect of the atmosphere, which is very important in defining the weather, that is the stability of the atmosphere. See, when I say stable, what I mean is, if a air parcel moves in the atmosphere, if the atmosphere is very stable, the air parcel will not go up or down till again come back to its original position. Like a pendulum, suppose I move a pendulum and leave it, after a few oscillations it will come back to its original position. This is called the stable position. The same thing happens in the atmosphere. When the atmospheric conditions are such that the atmosphere is stable, no weather can form. There will be no weather formation, because no air parcel can go up. They will all be lying wherever they are. But when the atmosphere is unstable, then what happens? The air parcel, when it starts moving, it will start keep on moving, and it will reach a level where large clouds will be formed. And these are the equations you can see in the slide. this T is actually the temperature of the parcel, T parcel, and this is the T, the temperature of the atmosphere. Whenever the temperature of the atmosphere is okay. You can see here the T parcel and T environment. T environment, what we mean is the temperature of the atmosphere, and T parcel is the temperature of the air. And whenever the temperature of the parcel is more than the temperature of the environment, what happens? The parcel is lighter, because higher temperature it is less dense, it starts moving up. To show you that, I have got a small visual here. You can see here this, in this visual there is a liquid body in this beaker, and I am putting a iron ball. When I put a iron ball, what happens? Because of its weight, it just goes down, and when I put a wooden ball, the ball starts moving up and it floats. That means the density plays a very important part. The density of the air parcel decides what will be the structure of the system. You can see here the wooden ball goes up, whereas the iron ball comes down because of density difference. That means the density is playing a very, very important part in the atmospheric conditions. Wherever the atmosphere is stable, there cannot be any weather. We give a fair weather condition, and wherever the atmosphere is such that it is unstable, that the air parcel are more hotter compared to the atmosphere, they starts moving up, and till they reach a point where they become clouds, and ultimately they rain also. Now, to show you that, there are two pictures here. You can see on the left side, it is a in over Beijing in one of the early mornings. What happens? This smoke plume, you can see it is almost parallelly going. It is parallelly going to the atmosphere. Sorry. Okay. The smoke plume is just going parallel to the atmosphere. That means, it is a stable condition. The smoke is not going up, whereas in the right side you can see the plume is just going up and up and up. It is moving up. That means, the atmosphere is unstable. This is over Baltimore in USA. This type of conditions happen everywhere over the earth, over India also in different parts, and whenever an unstable atmosphere occurs, you can be assured that by the afternoon or by the evening, lot of clouds would have formed and rain also would have occurred. But let me slightly warn you, this type of conditions may occur over, for example, over the desert areas of Rajasthan. That does not mean there will be rain, because what happens? There is no water vapor there. Over Rajasthan, it is a desert area, it is a dry area where there is no water. So, what happens? The heating actually rises dust. So, instead of rainfall, they will have dust storm. Dust storms will be there over areas like Rajasthan, whereas areas like Kerala, Karnataka, some of these areas where lot of lakes are there, rivers are there, ocean is there surrounding them, because of the lot of water vapor, and this water vapor goes up and forms clouds and ultimately rains. Now, let me show you how the stability plays a very important part in the formation of the rainfall. The key element is the density. That means, what is called as the buoyancy. What is the buoyancy of the atmosphere? What is the condition of the atmosphere? That decides the formation of the clouds. Here you can see here how the air parcel is moving, because it is a stable condition. The air parcel moves little up and then comes down. It is going up and coming down. It is not going further and forming the clouds. That means, there will be no cloud formation in a stable condition. When you come to unstable condition, it rises, and what happens? The atmosphere is unstable. That means, air parcel is lighter compared to the atmosphere. So, it goes up further. It further goes up, and it reaches a level when a cloud is actually formed. And like this, many parcels will be going up since morning, small parcels, and this all will join together and ultimately form a big cloud. And when the cloud is having sufficient water vapor, sufficient raindrops, then it falls as rain. And this process what is happening in the cloud, that is also very interesting. I would like to briefly touch upon that. Within the clouds you have got millions of drops, millions number of drops are there, and they are all small drops and they are floating. What happened? These drops are moving up and down and they are hitting each other, and a process called coalescence happens. Coalescence, that means the drops join together and they become a bigger drop. Again they hit each other, becomes a bigger drop, and ultimately a stage reaches when the drops are so big that due to the gravity they start falling down. So, rain actually is a process when within the cloud enough collisions have happened and number of drops have become smaller, but bigger drops are there, then only rain will form. This explains why on some days we see very dark clouds are there. It will look as if it is going to rain now, but there will be no rain, because what happens is there are not sufficient drops, enough drops to form larger drops and become rain. That condition is not there. So, what are the basic conditions? Let us just see. One is stability of the atmosphere, second one enough water vapor. These two are the basic conditions with which the rainfall occurs. Now, let us just quickly go through a few cloud forms. It is very interesting to see there are a number of cloud forms are there, and as I told you earlier, stratus, alto and cumulus, these are the three varieties. Stratus means very thin clouds, as you can see here in the first part of the slide, thin clouds are there and the sun is actually setting, and you can see the reflection from the sun coming down, the golden rays coming down, and this is a cumulonimbus clouds. These cumulonimbus clouds are actually cumulus and nimbus together. They are together and they are having lot of water content in the cloud, and these are all the thunderstorm clouds. These clouds form thunderstorm because during the process of this air parcel going up, due to friction, lot of electrons will be lost from the water particles and they become charged, either positively or negatively charged. And any cloud you see, there will be a positive part of the cloud charges, negative part of the cloud, and between these two positive and negative there will be lightning. If you are intently you have seen the observation, you can see within the cloud there will be lightning. In addition, there will be lightning from the cloud to the earth also. This happens when the cloud is so much charged, highly charged, it is able to break through the dielectric constant of the atmosphere and reach the earth. That is the stage when it breaks down the atmospheric condition, electric conditions, and it is able to hit some target in the earth. That is another type of lightning. So, this is the cumulonimbus, and this is the weather cloud. Basically, all the weather is formed due to this, and during the monsoon time when we get lot of rain, the cumulonimbus clouds are maximum. Then you have got the alto cumulus clouds, very interesting. You can see here lot of striations are there like roads. Actually, this is because the atmosphere is in a wavy form. In the atmosphere there are many waves, gravity waves are there, Rossby waves are there, and these waves are actually moving the clouds in such a way. So, actually people take observations of these clouds and then calculate the atmospheric waves, what are the conditions of the atmospheric waves. Another type of wave, let us see. Here you can see the clouds like cirrocumulus. This cirrus is at a height of 10 to 12 kilometers, and they will never give any rainfall. They are actually, after a weather has occurred, there is some remnant clouds are there. They are going up in the sky and just floating, and these are very useful to study the wind conditions at that height. At the height of 10 to 12 kilometer, we want to know what is the wind condition. We keep on observing this cirrus cloud, and with every 1 hour we observe, you know where they are moving and at what speed they are moving. And then you have got the cirrostratus. At the cirrus, at that level, stratus clouds are there, and see the beauty of the sunset, you can see through the stratus cloud. And this type of red color comes because very thin ice crystals are there. At the 10 to 12 kilometer ice crystals are there, and they are actually deviating their radiation and dispersion is occurring, and you are able to see the red color. And here you can see the stratocumulus. Stratocumulus occurs very near to the earth. Stratus means very near to the earth, within 2 to 3 kilometers, and cumulus means very less water is there, and they will be in the form of some cabbage or cauliflower. In that form it will be there. And this cloud is a weather cloud, cumulonimbus, and you can see a anvil. This is the form of an anvil in the top. The formation of the anvil means there is weather. There is going to be thunderstorm, there is going to be rainfall. So, always the weather forecasters, they will be looking for such signs in the clouds. And another type of clouds also you can see here, the altocumulus, then very thin clouds, altostratus and nimbostratus. Nimbostratus contains lot of water, and this also gives rainfall. So, now what you have seen, the different clouds, you can understand there are 3 levels, at a very low level, medium level and high level, and some of them only carry the rainfall capacity, not all clouds. That means, for forecasting, first of all we have to understand what clouds are formed, how much water vapor is there, and then how much potential is there for the rain. Now, let us see the principle of rain. What is the principle of rain? You can see here the process, the radiation coming from the sun makes the water evaporate from the surface. Evaporation occurs, surface is heated by the sun, air rises, air expands and cools, air condenses, because for all this process to happen you need water vapor. And you can consider our country India is surrounded by the oceans, Arabian Sea on one side, Bay of Bengal on the other side, and Indian Ocean on the third side, and only Himalayas on the fourth side. So, basically what happens, our country is surrounded by a large volume of water. Because of that, there is no shortage of water vapor over the country. Whenever there is instability is there will be immediately rainfall. Now, you can see here the process is the water vapor rises, forms clouds, and it rains, and this rain again flows to the lakes, rivers and ocean. This is called the hydrologic cycle. So, what is happening in the atmosphere? Whatever water is there, it rises up, goes to the atmosphere, again comes back. So, it is a circulation process, and this whole process is called as the hydrologic cycle. Now, forecasting of rainfall means we have to understand all these phenomena. Now, let us see what type of observations we do, what type of analysis we do. Before going to that, I will just briefly tell you about the precipitation. See, let us not think that rainfall means only liquid, only in the form of water drops. Water drops is one of the form of the precipitation, rainfall. Another form is snow. If you go to Himalayas, there will be no rain, there will be snow falling actually. Snow will be falling in the form of sheets like sleet it is called, or in the form of snow drops, snow crystals. So, in different ways the snow will be falling, and why there is snowfall there, but there is rainfall here, the basic reason is the atmosphere. You consider for example, a place like Himalayas, where by the time that from the cloud the rain comes down, it again becomes solid, it becomes snow and falls as snowfall. Whereas, over places like Kerala or Tamil Nadu or Karnataka, any part of India, what happens? The drops will remain as drops only, because the temperature of the atmosphere is high and they cannot solidify. So, they will be in the liquid form only, and they will come and fall down. And in extreme cases, where the cloud has formed at a very fast pace and there was no time for that to condense and all that, it becomes snow, and this is called hail, hailstorm. And one hail can be of the size of almost 10 centimeters by 10 centimeters or 20 centimeters by 20 centimeters, very heavy. If the hail falls on somebody, it can damage. In fact, crop damage occurs in Karnataka, Andhra Pradesh during the summer season only because of the hailstorm. And hailstorms are happening whenever the convection is very high, whenever the clouds are formed at very fast speed and there was no time for the drops to form, they directly fall as snow materials. Now, let us summarize today's talk on weather and the weather process. Basically, The points covered are: what is weather, what are the different steps involved in the formation of a cloud, what are the different atmospheric parameters including the atmospheric stability, and then we also covered the process of rainfall. The questions could be: define what is weather and how it differs from place to place. Second question: how the cloud is formed and what are all the important conditions of the atmosphere. Third point: define what is atmospheric stability, including the basic hydrostatic equation. Fourth question: explain the process of formation of rainfall. With this, we come to the end of this session. Thank you very much.